All right, so today we are starting to graph quadratics. Our goal for today is I can graph a quadratic in vertex form. So go ahead and pre-rate yourself on this topic. If you took Algebra 1 last year, you did do this, but I'm assuming that you oh yeah, I remember, but you don't remember how to do it. That's usually what we get here. But this is a piece of information that you need to hold on to because you do it in Algebra 2 with trig also, and then pre-calc we assume that you know how to do it. It's like if we assume that you know that 2 plus 3 is 5. So make sure that you realize that this is your long-term goal, is to make sure you're able to do this in the future, not just knowing it for the now. Okay. So it says, we have played around a bit in Desmos with graphs that involve a squared. I'm going to say that an x squared, it should say, an x squared. Now that we have some experience with these graphs, let's try to understand more of why they behave the way that they do. Okay? So, it says graph y equals x squared. We're going to graph it first by making a table. You're not going to use a table to graph them in the future. You're going to use them to get additional points. But we're going to use a table right now because we don't know where to even start. So let's plug in -3. Okay, so I'm going to plug in -3, so I need to know what -3 squared is. Okay, please realize that's -3 times -3, so that's +9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Now let's graph these points so we can form our parabola here. So I have -3, 9, -2, 4, -1, +1, 0, 0, 1, 1, 2, 4, and 3, 9. Then you can go ahead and connect your points. You want to put arrows on the end always to show that the graph goes on forever and ever. We just stopped our table. And also we're connecting these and not just leaving it as points because there's all those decimals in between that we didn't plug in that there's still y values that match up with those. Okay, next it's a little review here. What's the domain of the graph? So remember, to find the domain, you're going to look left to right. So if you look left to right, it goes from an arrow to an arrow. So your domain is from -infinity to +infinity. Now let's look at our range. We're going to look at the lowest our graph goes. Okay, so that's the lowest our graph goes. Here's the highest our graph goes. So the lowest our graph goes is not an arrow, it's 0. The highest our graph goes is an arrow, so that's infinity. Now remember, on infinity, you always put a parentheses. Now, I'm not going to put a parentheses on 0 because that would mean that, but don't include 0. There is a value at 0, so what we're going to use, if you recall, is a bracket. All right, so one thing that I want to talk about before we move on to the rest of the notes here is that notice this point right here is the vertex. Your vertex was 0, 0, okay? So that right there was your vertex. That's an important part of the parabola to make sure you know. All right, so what we're going to talk about today is vertex form. Now, when I have a parabola in the form y equals a times x minus h squared plus k, these are the following things that I know. Now, you did your Desmos activity and discovered these things, so hopefully you remember from that Desmos activity. All right, so if you recall, this h value right here moved your graph left and right. This k value right here moved your graph up and down, okay? So if I'm moving it right and down, I'm going to move it over h and up k. So once again, h moves the graph right or left, and k is going to move your graph up or down. Now it says if the absolute value, because remember the positive and negative thing has to do with the reflection here, but if a was a bigger number like 2 or 5 or 8.6, the graph got narrower. And if A was a smaller number, this should say in between 0, oh, it's the absolute value, so that's fine. If the absolute value is less than 1, so like a half, a fourth, 0.17, then the graph is going to get wider. Now, I said absolute value because it doesn't matter if it's positive or negative for that number, whether it's wider or narrower. The negative, if there's a negative in front of A, what did that do to our graph? The graph would then be reflected. And it'd be reflected vertically, so it'd be downward facing. All right, so let's try some of these. Notice that we have, the rest of this is just exploring graphing, okay? So you should see patterns, you should catch on pretty easily. So first off, in my vertex is HK. So here's H, which is 1, here's K, which is a positive 3. So it's 1, 3. Now you might be saying, is it negative? You always take the opposite of what's in the parentheses. So there's a negative 1 inside that parentheses, so that's positive 1. And then you always take this for face value, so positive 3. All right, so now what you're going to do is you are going to, let me get my eraser out here to erase that. You're also, whenever you get your vertex, you're going to put it in this table and you're going to put it right in the middle. If you noticed up here, our vertex is right in the middle because it's in the middle of your graph. So that's what we're going to always start by doing, okay? Now you can graph the 0.13. That's the vertex of our parabola. All right, now we need to know what the rest of our graph looks like, okay? So what I need to know is what it looks like to the right and what it looks like to the left. So I need 2 x values to the right. So if you look to the right, there's an x value here and here. So I'm going to do 2 and 3. And then I need 2 x values to the left. So here and here, oops, I went too far. I can do 0, right? Here and here, so I'm going to do 0 and negative 1. So if you look at my x values, they're going in order negative 1, 0, 1, 2, 3. So you don't have to use your graph paper from them. You can just say I need 2 values bigger, 2 values smaller. All right, so now how am I going to get my y values? I'm going to get my y values by taking my x values and plugging them into my equation. Okay, so let's start with the 2. So I'm going to plug in a 2 there. 2 minus 1 is 1. Then I have to square it and add 3. 1 squared is 1. 1 plus 3 is 4. Now I'm going to plug in the 3. 3 minus 1 is 2. 2 squared is 4. 4 plus 3 is 7. Now I'll plug in 0. I have 0 minus 1 is negative 1. Negative 1 squared is 1. 1 plus 3 is 4. And finally, I'll plug in negative 1. Negative 1 minus 1 is negative 2. I got to square it and then add 3. Negative 2 squared is 4. 4 plus 3 is 7. So what you should notice here is that these values were the same and these values were the same. That's because our graph is symmetric. So really, if you do work for 2 of them, you don't have to do work for the other 2. All right, so let's graph our other 4 points. I have 2, 4, and 3, 7. And then I have 0, 4, and negative 1, 7. Then I can go ahead and connect my points, put arrows on the end here to form my parabola. My domain, it goes from an arrow to an arrow, so negative infinity to positive infinity. My range, the lowest my graph goes is 3, the highest it goes is an arrow. So my range is from 3 with a bracket, because there's a value there, to infinity. See that? All right, let's try a couple more, and then you can try a couple on your own. First off, I need my vertex, right? So notice I'm not asking you for an extra spot for your vertex right here, but you need it to graph. That's what you're going to get first always. So here my vertex is 4, negative 5. Now I need 2 values bigger than 4, so I'm going to do 5, 6, 2 values smaller, 3, 2. You always want these in ascending order here. Okay, so you always want them, you don't want the 2 and 3 to be mixed up. Okay, now I need to plug in 5. So I'll do the work down here, okay? I'm going to plug in 5. 5 minus 4 is 1, and then I have to square it, and then subtract 5. So that's 1 minus 5, which is negative 4. And that means this is negative 4 also, right? So I don't have to do that work again. Then I'm going to plug in 6. I'll do that work down here. So I'm plugging it in right here. 6 minus 4 is 2. And then I square it, minus 5. That's 4 minus 5, which is negative 1. Now I can graph all 5 of my points. I'm going to start with my vertex, 4, negative 5. Then I have 5, negative 4. And I also have 3, negative 4. And then I have 6, negative 1. And I also have 2, negative 1. And I can connect those. And there's my parabola. My domain, it goes from an arrow to an arrow, so all real numbers, negative infinity to positive infinity. The lowest my graph goes is negative 5. The highest it goes is infinity. All right, so let's go ahead and try this next one here. Okay, so first off, I need the vertex. Now, what you should notice about H is located inside the parentheses. There are no parentheses here, so if you want to draw them in, you can. But where on earth would I draw them in? If you're drawing in parentheses yourself, you're drawing them only around X, right? So if there's none there, that means it's because it's only around X. That's why you don't need them. All right, so what is H? What's being subtracted off of X? Nothing. So that's 0, and then K is 3. And when I say what's H and what's K, remember, H, K. Okay, so I need two values bigger than 0, 1 and 2, and then less, negative 1 and negative 2. All right, I'm going to start by plugging in 1 into my equation right here. So I have negative, and I'm going to plug in the 1, square it, plus 3. All right, so let's make sure we understand what this says. Do I do negative 1 squared or do I do 1 squared? I do 1 squared first. Okay, so what's 1 squared? It's 1. Now I have to take the opposites. That's negative 1 plus 3, 2. Now I'll plug in 2. So I have the negative, and I'm going to plug in 2, square it, and then plus 3. 2 squared is 4. Take the opposites. This is negative 4 plus 3, which is negative 1. Now, really quickly, I'm going to pause time out and make sure we know the difference between what we just did here and this. This says square negative 2, which is 4. 4 plus 3, which is 7. This doesn't. So make sure you know the difference between the two. Otherwise, you're not going to get a parabola, and you should know you're making a mistake. All right, 0, 3, 1, 2, and also negative 1, 2. 2, negative 1, and negative 2, negative 1. So this time, oops, I don't like the way that looks. There we go. This time, you get a downward facing parabola. My domain goes from an arrow to an arrow. So all real numbers, negative infinity to positive infinity. Now for this one, the lowest my graph goes is an arrow pointing down. So that is negative infinity. And remember, we always put a parentheses on that. The highest my graph goes is 3. And there's a value there, so I'm going to use a bracket. Okay? Why don't you go ahead and pause the video and try these two on your own. I'll go ahead and fill them in real quickly so you can check yours. Your vertex is negative 2, 1. Two values bigger are negative 1 and 0. Negative 3 and negative 4 are smaller. I'm going to plug in negative 1. Negative 1 plus 2 is 1. Square it, plus 1. 1 plus 1 is 2. Plug in 0. 0 plus 2 is 2. Square it and add 1. That's 4. 4 plus 1 is 5. So I have negative 2, 1. Negative 1, 2. And negative 3, 2. Oops. 0, 5, and negative 4, 5. There's my parabola. Domain, all real numbers, so negative infinity to positive infinity. My range, the lowest my graph goes is -1. The highest my graph goes, or no, it's not, it's +1. The highest my graph goes, infinity. All right, next one here, I need my vertex HK. So H is 4 and K, there's nothing on the end, so that's 0. I need two numbers bigger than 4, so I'm gonna do 5 and 6, smaller, 3 and 2. I'm gonna plug in 5, so I have the negative in front, and then I have the parentheses squared. All right, so plugging in 5, I get 1. So remember, you do 1 squared first, which is 1, then take the opposite, that's -1. Negative, now I'm gonna plug in 6. 6 minus 4 is 2. So I have 2 squared, which is 4. Take the opposite, that's -4. So I have 4, 0, 5, -1, and 3, -1, 6, -4, and 2, -4. Also notice parabolas are smooth curves. There's no straight lines in parabolas. My domain, all real numbers. Lowest my graph goes is an arrow. The highest it goes is 0. So negative infinity to 0. All right, so it says, we have also seen that multiplication in front of the graph may stretch it a bit. So graph each of these and see what happens, right? And we're gonna do it on the same axis. So we're gonna color code this so that it matches up. We'll do y equals x squared in blue. So remember, this was 9, 4, 1, 0, 1, 4, 9. You can graph that. 0, 1, 1, 2, 4, 3, 9. And remember, it's symmetric, so I'm just matching up these points really when I'm graphing. All right, there's the parent function. Once again, remember, this is called the parent function. It's without any movement. Up, down, left, right. It's not narrow, it's not wider. All right, now let's see what the 1/2 does. Now, if you recall, we already wrote down what the 1/2 is going to do. It's going to make it wider. But let's actually physically see by plugging in numbers that it makes it wider. So I'm going to change this to red here. Let's plug in -3. -3 squared is 9, but then I have to take half of 9, which is 4.5. -2 squared is 4, but I have to take half of 4, which is 2. -1 squared is 1, but I have to take half of 1, which is a half. 0 squared, 0, take half of 0, that's still 0. And then once again, I get 1/2, 2, and 4.5. All right, so -3, or actually let's graph our vertex first. So notice it didn't move up, down, left, or right, right? So we have the same vertex. Then we have -1.5 and 0.5. Positive 1.5. We also have 2, 2 and -2, 2. And then we have 3, 4.5 and -3, 4.5. So you can see right here that the graph did get wider, like so. Okay. So once again, that 1/2 is going to make your graph wider. If it was a 2, your graph would have gotten narrower. So it says, let's graph 2 examples with the stretch together, and then you're going to try 2 on your own. Okay, so we'll start with this one. First off, I need my vertex. Now, notice once again, there are no parentheses in here, so if you want to add them, where am I adding them? Only around x, right? Okay, so now I can see what my vertex is. There is nothing being subtracted off of x, so that's 0. And then k is -8. I'm going to plug in a 1 here, 2 here, -1, -2. Now this graph should be getting wider, or sorry, narrower if I'm doing it correctly, because the 2 is going to make it narrower. All right, let's see our numbers here, and then we'll graph it. All right, so I have 2, I'm plugging in, that's that 2, and I'm going to plug in the 1, square it, and then subtract 8. 1 squared is 1, 1 times 2 is 2, 2 minus 8 is -6. Now I'm going to plug in 2, so I have the 2 in front, and I'm going to plug in 2, square it, and then -8. Okay, so remember, you square the 2 first, that's 4. 4 times 2 is 8. 8 minus 8 is 0. All right, I can go ahead and graph this parabola. I'm going to graph the vertex first because I like to. 0, negative 8. Then I have 1, negative 6, negative 1, negative 6. 2, 0, and negative 2, 0. So you can see this graph is much narrower than what we have been graphing. The domain still goes from an arrow to an arrow, so negative infinity to positive infinity. The lowest my graph goes is negative 8. The highest it goes is infinity. Always a parentheses on infinity. And then since there is a value at negative 8, we're using a bracket. All right, let's try one more together. I need HK. H is negative 3. K is 1. I need two values bigger than negative 3. That's negative 2 and negative 1. Smaller, negative 4 and negative 5. All right, let's plug in negative 2. And yes, you can plug in negative 2 or negative 4. I just like plugging in the bigger numbers. So I have negative 1/2 times, and then I have to plug in negative 2. Negative 2 plus 3 is 1. And then I square it and then add 1. Okay, so now I got to do this math. 1 squared is 1. 1 times negative 1/2 is negative 1/2. Negative 1/2 plus 1 is a positive half. Or you can put 0.5. All right, now I'm going to plug in negative 1. So I have negative 1/2. I'm plugging in negative 1 here. Negative 1 plus 3 is 2. And then square it plus 1. Okay. Square the 2 first, that's 4. 4 times negative 1/2, it's a negative number, and then I'm just taking half of 4, which is 2, adding 1, that's negative 1. All right, so I have, my vertex is negative 3, negative 1. Then I have negative 4, positive 1/2, and negative 2, positive 1/2. And I have negative 1, negative 1. And I have negative 5, negative 1. Okay, so as you can see right here, I've made a mistake. Now, I might be saying to myself, oh, I'm just going to connect them. That would be the wrong thing to do. I have to figure out what my mistake is. Okay, I have to figure out what my mistake is because it's not making sense. So let's see. First off, I'm going to check, is my parabola supposed to be facing upward or downward? My parabola is supposed to be facing downward. Okay, so my vertex is supposed to be at negative 3, positive 1. I graphed it at negative 3, negative 1. So my other points were just fine. I just graphed my other point wrong. And see how easy it was to figure out your mistake? Okay, so please make sure you're trying to figure out your mistakes instead of just connecting what you have. It has to form a parabola still. Okay, now I'm going to do my domain and my range. So my domain is still all real numbers, negative infinity to positive infinity. My range, my lowest my graph goes. So I want to know what's the lowest it goes. The lowest it goes is an arrow, so negative infinity. What's the highest it goes? 2. Always a parentheses on infinities, and then 2 is included, so a bracket. And that's not, I graphed that point wrong still. It's not supposed to be 2. Oh, Mrs. Dillon. There we go. Much better. And now I can fix it because it's supposed to be a 1. Now, how did I catch that mistake? I was like, because my vertex is at negative 3, 1, there's no values at 2 right here. There's no way, right? Okay. Go ahead, pause the video. Try these two on your own. Also try to think of what's gonna happen before you do it. All right, so 1/4 should make this graph wider, and 2 should make this one narrower. Just to make sure, this is also should be facing downward. Okay, if you want to add your parentheses in, you can. So there's no H, K is 2. I'm going to plug in 1 and 2, reflect negative 1 and negative 2. Plugging in 1, I have 1/4 times, and then I have to plug in a 1, square it, add 2. 1 squared is 1. 1 times a fourth is a fourth. A fourth plus 2 is 2 1/4. Now I'm going to plug in 2. So I have 1/4 times 2 squared plus 2. 2 squared is 4. 1/4 times 2 is 1. 1 plus 2 is 3. Now I can graph my points. My vertex I'll start with 0, 2. Then I have over 1 up 2 1/4. Over -1 up 2 1/4. And then 2, 3. And -2, 3. My 2 1/4s are wrong. There we go. 2 1/4, 2 1/4. There we go. It just didn't feel very parabola-like. It didn't feel very U-shaped. All right, my domain, all real numbers, -infinity to +infinity. My range, the lowest my graph goes is 2. The highest my graph goes is infinity. Always a parentheses infinity. 2 is included, so bracket. Notice it did get wider. Okay. Last but not least, my vertex here, h is -1, k is 6. Values bigger than -1, 0 and 1, smaller, -2 and -3. So we're going to start by plugging in 0. So I have -2, plugging in 0, 0 plus 1 is 1, 1, and then square it. So 1 squared is 1, 1 times -2 is -2, -2 plus 6 is 4. Now I'm going to plug in 1. All right, 1 plus 1 is 2, so I have to plug in a 2 there. Or not plug in a 2, but have that be a 2. Square the 2 first, that's 4. 4 times -2 is -8. -8 plus 6 is -2. So 0, 4. No, that's not my vertex, but I have to erase it. I feel like I need to. All right, -1, 6. 0, 4. And -2, 4. And then 1, -2. Oops, that's not -2. 1, -2. And -3, -2. And there's your downward facing parabola that you said would get narrower. My domain is still from an arrow to an arrow. My range, the lowest it goes is -infinity. The highest it goes is 5.